So the last subtopic in logic is predicate calculus and quantifiers. So what is predicate calculus and quantifiers? Okay, in propositional calculus, the augmented system of symbols and rules is called predicate. The true values T or F can be given to each predicate calculus. Okay, quantifiers. So quantifiers is a symbols for mathematical shorthand which involves with quantity. Okay, so here you can see that we have universal quantifier, existential quantifiers. So for the universal quantifier, we're going to use the symbol this one, A terbalik. Or we can read like this, for all, for every, for each in every case. So I love to use for all. So if when I look at these symbols, I can say, I will say that this one is for all. Okay. Otherwise, this symbol, E terbalik, we can read like this, at least one. At least one. Okay. For example, for all x px. So meaning that you can read as for all x in px. For all x in px. Okay, the second one is at least one x px. So you can read like this, there exists an x in px. Or you can say that there exists at least one x in px. Or you can say that at least one x exists in px. Okay. So the statement for all x in px, it can be the true statement or the false statement. So for the true statement, so meaning that px is true for every x. So meaning that px here is true for every x. But for the false statement, so there is an x for which px is false. Okay. So this one, there exists an x in px. The true statement is there is an x for which px. Okay. So for the false statement, px is false for every x. Okay. How about if the true quantifiers of two variables? For all x, for all y, in px and y. So for the true statement, px and y is true for every pair x and y. For the false statement, there is a pair x and y for which px and y is false. Okay. For all x, at least one y in px and y. So for the true statement, for every x, there is a y for which px and y is true. Okay. There is an x such that px and y is false for every y. Okay. At least x and for all y in px and y. So there is an x for which px and y is true for every y. Or for every x, there is a y for which px and y is false. Okay. At least x and at least y, px and y equal to at least y, at least x, px and y. So meaning that you can write like this. You can write at least x, at least y. Or you can also write like at least y, at least x. So this is the same. Same, x and y. Okay. Here also you can write for all x, for all y. It's the same with for all y and for all x. Okay, look at the example. Get the example. For all x, at least y. For the statement x plus y equal to 1. So the easiest way to understand is, you must understand like this. Untuk semua x, meaning that here for all x, sekurang-kurangnya mesti satu Y yang betul. Mesti ada satu Y yang betul. Untuk semua nilai X, sekurang-kurangnya mesti ada satu nilai Y yang betul. So, kita kata, we can say that this one is true. Tapi, but, if, let's say, for all X, tak ada, there is no Y yang betul, so this statement is false. Okay, tengok contoh, for example, X plus Y equal to 1. So, here, X and Y. So, X here, we put 1 here. Y, we test with 0 and 1. Okay, X plus Y. So, when X is 1, okay, 1 plus 0, you will get 1. So, this statement, X plus Y is equal to 1. So, meaning that is true. But for X is 1, Y is 1. So, this one is 2. 2 here, this one, they want X plus Y equal to 1. So, the statement is false. Okay, let's say we test with another numbers. If X equal to 2, Y equal to 0, you will get 2 here. So, meaning that is wrong. If X equal to 2, Y equal to 1, so you will get 3. So, wrong. If X equal to 2, Y equal to negative 1, so you will get 1. So, correct. So, here you can see that untuk semua X, sekurang-kurangnya mesti satu Y yang betul. So, kita tengok, when you look at here, if X equal to 1, untuk semua X ni, okay, ada tak satu Y yang betul? So, ada. So, here. So, untuk X ni, untuk semua X, so, semua X ni equal to 1 lah, here. So, for this one, X, 1. For this one, untuk X, untuk semua X is equal to 2 here. So, ada tak yang betul? So, ada satu betul. So, bila ada satu betul, so this statement we can say that true statement. Tapi, kalau let's say we kat sini salah, katakan ini salah. So, meaning that this statement is false. Dia nak sekurang-kurangnya mesti ada satu juga Y yang betul. So, betul, so betul. Okay, let's see another example. Okay, at least X for all Y untuk X plus Y equal to 1. So, untuk yang ni, awak boleh kata untuk setiap X mesti betul untuk kesemua Y. Untuk setiap X mesti betul untuk semua Y. So, maksudnya kat sini, X ni kita guna satu-satu. Untuk semua X ni, mesti betul untuk semua Y. But when we test X plus Y, we're gonna get 1 plus 0 equal to 1. 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. So, this one is true, but this one is false. So, meaning that this statement is false. Because dia nak untuk semua X ni, mesti kita kena betul untuk kesemua Y. Tapi kita dapat satu je betul. Yang ni salah-salah. So, kita kata statement ni salah lah. Okay, katakan for example, for all, at least X for all Y, XY is equal to 0. So, X here, you use 1. Or X here you use, I think you use 0 here. 1, 2, 3. So, here, XY, 0, 0, 0. So meaning that here is true, true, true. So untuk setiap X, for all X, mesti betul untuk kesemua Y. So semua betul. So this statement is true. Okay.